is an angle bisector? Yes, sir.
A line, segment, or ray that divides an angle into two congruent angles.
All right, a ray, a line, a segment that divides a angle into two congruent segments. What do we know about the angle bisector? If I know that a ray is an angle bisector, what do I know? What does the theorem say? What does my angle bisector theorem say? Isaac.
If the point's on the bisector of the angle, then the point is equal distance from the two sides of it.
Okay, so if a point is on the angle bisector, let's say point D, on the angle bisector, it is equal distance from the sides of the angle. Is AD equal to DC? Is AD equal to DC? And carefully, remember in the video, what did we say about distance? Distance from a point to a line must be perpendicular. Perpendicular. I can draw many lines from that point to that side of the angle, but they would not be the shortest distance. So I need to make sure that the two lines are perpendicular. And again, I didn't draw my angle bisector directly in the middle. But if the two segments are perpendicular, then I know that those two distances are equal. I can say that AD equals DC, if those were the points there. So an angle bisector. If I know that AD is equal to DC, then I can say what? Yes?
ED by, segment ED bisects angle ABC.
Correct. So I can say that that segment bisects that angle, to say it, because it's equal distance. Angle bisector theorem. And then the converse. So we talked about mid-segments, perpendicular bisectors, angle bisectors. And then 5.3, bisectors and triangles. So here we have perpendicular bisectors. Perpendicular bisectors, I know what?
They're the circumcenter.
But it just, but it doesn't matter if it's in a triangle or not. What do I know about a perpendicular bisector? Yes,
It bisects at the midpoint.
that's correct. But the perpendicular bisector theorem tells me what? Perpendicular bisector theorem, what does it tell me? Yes?
Isn't it, it's an equal distance to the intersection to all the points.
Alright, but if I'm just talking about a segment, perpendicular bisector of a segment tells me what?
That if the point is on the perpendicular bisector of a segment, then it's equal distance from the point.
So it's equal distance. So that means if this is the point on the, then I know that these distances are going to be equal from the vertices of the triangle. This point is called what kind of point?
Circumcenter.
No, that's not the one I'm looking for.
The point of concurrency.
Alright, point of concurrency, a concurrent point. Concurrent point is a point where two or more lines intersect. And again, if I draw the third perpendicular bisector, it would be there as well. Alright, so now the concurrent point of perpendicular bisectors in a triangle are called what? The concurrent, what is it? The circumcenter, which is what?
The middle of the smallest circle that the triangle can be inscribed in.
Alright,
That is it.
and again, it's not the smallest, it's just the only one. It's the only circle that will be circumscribed about the triangle, or the triangle inscribed inside the circle. So where's the circle? On the outside.
Couldn't it be a bigger circle?
Not for it to be circumscribed, for the circle to be circumscribed, all the vertices, all the corners must be touching the circle. Alright? So all these corners must be touching the circle for it to be a circumscribed circle, or an inscribed triangle. Now we talked about three different ways that we could have a circumcenter. If I have a acute triangle, where would the circumcenter be? If I have an acute triangle,
In the middle.
alright, it would be inside the triangle. If I have a right triangle, where would the circumcenter be? On the hypotenuse in the middle. Alright, on the midpoint. If I have an obtuse triangle, where would the circumcenter be?
Outside.
Outside the circle. Outside the circle. So again, here's my right triangle. If I do angle, perpendicular bisectors, it intersects the hypotenuse. And here's my obtuse triangle. Let me make this a little bit more obtuse. Let's go here and here. There's my circumcenter on the outside of the triangle. So I need to know those three concepts. Okay? I need to know perpendicular bisectors of the sides of a triangle will be concurrent. Where? What's the name of the point?
Point of concurrency.
But what's the name of the point? Circumcenter. Alright? Where will the circumcenter in a acute triangle be? Where?
Inside.
Inside the circle. Or sorry, inside the triangle. Where will the circumcenter of a right triangle be? Alright, now hypotenuse, the midpoint. Where will the circumcenter of a obtuse triangle be? Outside the circle. Then we talked about angle bisectors. Angle bisectors are also concurrent. And the name of that point would be the incenter. The incenter. The incenter is the center of what?
The inscribed circle.
The inscribed circle. The inscribed circle means it's inside the triangle. There's only one. The sides or the edges of the circle must intersect all the sides at one point. In other words, the sides of the triangle must be tangent to the circle. The incenter, what do I know about the incenter? Besides being the center of an inscribed circle.
to the perpendicular
Equal distance to the sides. So there's my inscribed triangle. Equal distance to the sides. End center, equal distance to the side. Circumcenter, equal distance to the vertices, the corners of the triangle. The end center, the circle is where? Inside. Circumcenter, the circle is where? Outside. Where is the center of a right triangle of a circumscribed circle? I said that wrong. Where is the center of the circle of the circumcenter? Hypotenuse. Where is the center of a where is the, get my question right here. Where is the circumcenter in a right triangle?
midpoint of the hypotenuse.
Where is the circumcenter of an acute triangle? In the inside of the triangle. Where is the circumcenter of an obtuse triangle? Outside the triangle. Where is the end center of a acute triangle? Inside the circle, triangle. Where is the end center of a right triangle? Inside. Where is the end center of an obtuse triangle? Inside. Hence we get end center, always inside, inside, inside of our triangles. Okay? So, the concept so far. Mid-segment. Perpendicular bisectors. Angle bisectors. Circumcenter. End center are our concepts so far, lesson 5.1, 5.2, and 5.3. Mid-segment, perpendicular bisector, angle bisector, circumcenter, and end center. Alright, the question they ask you is to find the circumcenter of the points of these three segments. So first of all, we would graph -7, 3. -9, 3. And -7, 7. That went the wrong way. Sorry. Alright, so what kind of triangle do we have?
Right triangle.
Right triangle. And I know the circumcenter of a right triangle is where?
Midpoint of the hypotenuse.
Midpoint of the hypotenuse. How do I find the midpoint of the hypotenuse? How do I find the midpoint of anything?
The square root of the change in
B, A plus B over two.
What's that?
A plus B over two.
A plus B over 2. Alright, you were trying to give me the center, or the distance, the square root. Midpoint, A plus B over 2. So what's my midpoint of my x's?
1.
1. Negative 7 plus 9 is 2. Divided by 2 is 1. What's the midpoint of my y's?
5.
5. So where is my circumcenter?
What is that?
1, 5. Alright, so again, we want to graph and then look at where my circumcenter would be. Let's see. Anybody have any questions so far?
There was one problem in the homework, that I had a little trouble doing this. Can we come back to it?
Yes. Turn to page 288. All right, number 7, page 288. Identify parallel segments. Connor, give me one. One pair.
Segment TV and one segment is parallel to segment YW.
All right, and Lauren, give me another one.
Segment UW is parallel to segment TX.
Okay, and Roy, give me another one.
YW is parallel to TV.
All right, make sure you, when you're stating it, you tell me you're naming a segment, okay? So I say segment TV, that way I know you're just naming a segment, not a line.
Okay.
All right, and Stephanie, give me another one.
Segment YU is congruent to segment XV.
Okay, very good. Number 9. All right, name the segment that is parallel to the given segment. And Alexander, number 9, segment AB.
Segment FE.
All right, number 11, Caleb, segment EF,
I don't know what page we're on, sorry.
page 288.
I found it also. Segment AB.
All right, number 13, Schuyler, segment GE is parallel to
Segment AC.
AC. All right, next point, E, D, and H are midpoints of triangle TUV. UV equals 80, TV equals 100, HD equals 80. What is HE? Elon?
Maybe 20.
No. How do you figure a 20?
Isn't so TV is 100 and then HD 80.
All right, remember, mid-segments are always what? What's the concept with mid-segments? Parallel to the third side and also 1/2 of the side is parallel to. Okay, so we're trying to find,
So it'd be the half of 100.
is HE parallel, what is HE parallel to?
VU.
VU, so it'd be 1/2 of VU.
Oh, okay, so then it'd be 40.
40, correct.
Okay. I was doing half of like TV because then it did 15.
Right. So it's always 1/2 to the segment it's parallel to.
Right.
All right, TU, Roy? $160, correct. Number 19. All right, find the value of x. Akira? 13. 21. Aaron? 6. 23. Abby?
Um, 13. No. Can I write it out?
Mhm.
Seventeen?
17, correct. 25. Isaac? 156 meters. 31. Connor?
31, right?
Mm-hmm.
Oh, then it'll be 50.
Okay. 33. Lauren? 100. Very good. All right. 35 on the next page, number 35. IJ is the mid segment. IJ is 7. FH is 10. And GH is 13. Find the perimeter of each triangle. Perimeter IJH. Roy?
There's 12.
Not quite. Tell me your thought process. Looking for the perimeter of IJH. What do you know about I?
Wait, is it 17?
You can get closer. What do you know about I? Because IJ is a mid segment, you know I is going to be the midpoint. Okay, so I is the midpoint, so that means IH would be, how would that IH relate to HF? If I is the midpoint.
HI would be 5.
5, correct. So HJ would be,
HJ would be 6.5.
6.5, and IJ, they tell you, is
Is 7.
7. So perimeter, we would do what?
So it's 18.5.
18.5, very good. All right, and while we're right there, 36, perimeter of FGH. Stephanie?
37?
Correct, 37. 38, Alexander.
60?
60. 39, Caleb.
50.
50. 40, Shyler.
Is it 10?
10, very good. 41. Elon, give me X.
was 40-10? Wouldn't it be 120?
No. Cause the 60 is talking about the angle, not the side.
You have to figure out that it's an
Equal that or triangle,
amount.
so all the angles are equal, that means all the sides are equal. So if the mid-segment is 5, then the side would have to be 10.
And then we're gonna do the 41.
Alright, 41. Alright, you're looking for x, right?
Yeah.
What do we know about x? It's the mid-segment, right? Because it connects to the midpoint,
Yeah.
okay? So therefore, what do we know about the mid-segment? It's gonna be,
Midpoint.
but what did we talked about earlier? We said it's gonna be how much of the side parallel to it? Half of it.
Right.
Okay? So that means x is gonna equal what? What did we say it was? The mid-segment is
Half.
half of
The triangle like that.
the side parallel to it, right?
Yeah.
What side is parallel to it? What side is parallel to x?
Y. Yeah, the opposite, right?
Correct, which is? What side looks like the sides of a railroad track with x?
See, cause this one, we went the opposite, would be right here. This would be across from it.
No.
Yeah.
Here. Cause this looks like this.
Oh, okay, okay. So this side with the 3x minus 6 would be the opposite side of it.
Correct.
Okay.
So that means x is gonna be, how much of that?
Half.
Half. Okay? How do I get rid of the 1/2?
Distribute it.
Alright, how else can I get rid of it? What can I multiply by to get rid of it?
The 2.
Okay? Now how can I solve that? Okay, get my x's together, so which one you wanna move?
The 2.
Wanna move the 2x?
Yeah.
So you move it over that way, that makes it what?
5. 5x.
Think again. When I move it and then I'm gonna add it or subtract it.
Oh, subtract. So it'll be 1.
Alright, now what do you wanna move?
The 0.
Now you wanna get x by itself, remember?
So then add 6.
Alright, so you wanna move the 6?
Yeah.
So x equals
6.
6. There you go. Alright, so the mid-segment. Anybody have any questions on mid-segment? Alright, flip over to $296. Looking down at number 12, starting at number 12. Alright? Ms. Yao, number 12. According to the diagram, how far is L from HK and from HF? How far is L from HK and HF? What do I know about HL? Anybody? It's an angle bisector, correct? And what do I know about an angle bisector? Any point on the angle bisector is equidistant from the sides of the angle. So how far is L from HK? 27. How far is L from HF? 27. Number 13, how is HL related to angle KHF? Kiara? It is the angle bisector. Number 14, what is the value of Y? Aaron?
9,
Excuse me?
9,
Okay, how do you know 9?
because 6y, with congruence, you can say 6y equals 4y plus 18, and move minus 4y, so you have 2y equals 18, divided by 2.
Okay, very good. It says find measure of angle KHL and measure of angle FHL. Abby?
54.
54 degrees, correct. Number 16, Connor. Find X.
X equals 12,
All right, how do you know?
because KJ is equal to JM.
How do you know that?
Because JL is angle bisector.
And you know the angle bisector is?
What?
You know the point on the angle bisector is?
Equal distance, is equidistant
To the
sides.
sides, correct. All right, very good. Number 18, Lauren, what's the value of X?
5.
5. Roy, what is TW? 10. And Elon, what's WZ?
It'd be 15.
What do we know about WY? WY is a,
Angle bisector.
no, look at it again.
Oh, right angle.
All right, so it's a perpendicular bisector. All right, so if a perpendicular bisector is equal distance from the endpoints, correct? So therefore, if TW is 10, WZ would also be 10 as well. All right, so tonight, what you are working on page 342. Is it there? Page 342, numbers 4 through 20. Numbers 4 through 20 on page 342, yes. Page 342, 4 through 20. You don't have to do number 7. All right, don't have to do number 7. Do all the rest though. Should be fairly easy. 4 through 20, not number 7.
Yeah, this one's right.